There are many indicators of global warming, one of which is Arctic sea ice. More than just an indicator, sea ice itself can have an important effect on climate. The more ice there is, the more energy gets reflected back into space. As ice melts, the Arctic is less reflective and absorbs more energy, resulting in even further warming. Furthermore, sea ice is fundamental to Arctic ecosystems and the species they contain. The Arctic is a very dynamic place with lots of changes happening across the seasons and from year to year. But the decline in sea ice that we've seen over the last 3 decades is quite striking. However, there are those who are trying their best to convince you otherwise. First, let's look at some claims, and then let's look at the data. According to Lord Christopher Monckton, Arctic sea ice is just fine. This is from a testimony to the United States Congress showing 2 visual snapshots of sea ice concentration in January of 1980 and 2009. He again shows these images in one of his reports for the Science and Public Policy Institute, or SPPI. Here he concludes that sea ice has scarcely declined in 29 years. Not only is sea ice apparently just fine, there are even claims that it's rebounding. In the film Not Evil, Just Wrong, Patrick Moore says that Arctic sea ice is not disappearing the way that we've been told. As a matter of fact, it came back even larger last year, and this year looks like it's going to be even more extensive. By this year, he's referring to 2009. Lord Monckton also highlights this, informing us that the summer minimum sea ice extent has grown 24% in 2 years. Sounds impressive. Well, instead of looking at a few visual snapshots, let's actually plot the data. I'm showing the Arctic sea ice extent in millions of square kilometers during September for the last 3 years. Sea ice extent represents the area covered by at least 15% ice. These 3 data points here represent the so-called rebound, the 24% increase, which doesn't mean as much when starting at such a very low value like we saw in 2007. More importantly, though, this doesn't mean all that much when you decide to look at the other 26 years of data. Whoops, they somehow forgot to mention that part. It's hard to call it an increasing trend when you're talking about the 3 lowest values on record and when the 3-decade trend is unquestionably downward. In fact, the quote-unquote rebound only brings sea ice extent back to the declining trend line. So as far as a rebound is concerned, the entire 29-year data set says otherwise. But instead of just showing the sea ice extent data from September, where we'd expect the greatest decline, let's show all of the data to make sure I'm not leaving anything out. So here's the 30-year sea ice extent trend for the month of January. We can see lots of year-to-year wiggles, as we would certainly expect, but the trend line is significantly negative, now nearly 1.5 million square kilometers below where it was in 1979. To give you some perspective on the size of 1.5 million square kilometers, think about the entire West Coast plus Nevada and Arizona. Not trivial. So let's keep going and look at all the data for all the months of the year. There's been a decline in February ice, March, and April. May has seen the lowest decline of just over 1 million square kilometers. But as we start to enter the summer melting season, we begin to see the largest declines, as expected, with warming temperatures. And here's the September sea ice minimum again, showing a decline of nearly 2.5 million square kilometers. What does that look like? Think of the U.S. east of the Mississippi, or the Mediterranean Sea, or 1.5 Alaskas. For those that study this, and for the organisms that depend on sea ice, this is a very big deal. But according to Lord Monckton, it's just fine. As we begin to move back into the winter, we see continued declines for each month. So now I'm showing you the Arctic sea ice extent for every month of every year for which we have comprehensive records. No matter how you look at it, there's no conclusion other than Arctic sea ice extent is declining. Well, unless, of course, you base your conclusion that sea ice is just fine on only 2 data points, the first which happens to be below the trend line and the second above, and then you happen to show this in a testimony before Congress. Or unless you show only 3 data points and claim that sea ice is growing rapidly and ignore the preceding and dominating decline. So those claims that sea ice has hardly declined in 29 years and has instead grown by 24% are really based on only 1% of the total available data on sea ice extent. Wow. When looking at all the data, you can't escape it. Sea ice extent is declining. But there is another figure that Lord Monckton often uses, which does show more data. However, it's not a figure that can easily convey anything about long-term changes in sea ice. Each line in this figure is the sea ice extent for different years, but only beginning in 2002. The most obvious pattern is that there's more ice in the winter and less in the summer. The data in this figure are really just a subset of the data that I just showed you, except that they are presented in a different way, which makes it very difficult to see any long-term changes across years, especially as this only includes 8.5 years out of 30. This figure is useful for comparing the current sea ice extent in red to recent patterns in sea ice. We can see that as we head into the melt season, 2010 sea ice is tracking at the low end, and the sea ice extent for July 2010 was the second lowest behind 2007. Okay, so I've talked a lot about sea ice extent, which is an important measurement of sea ice, but it doesn't take into account the fact that ice also has a thickness. If we really want to know how much ice there is, we should be thinking in terms of volume, not area. These 4 images show sea ice in terms of its age. The purple represents thin, first-year ice, light blue is 2-year-old ice, and green represents older, thicker ice. The top left shows the average from 1981 to 2000, and you can see lots of green, meaning lots of old, thick ice. When we look at 2007, we see the record low ice extent, but then look at what kind of ice there is during the so-called rebound in 2008 and 2009. During these 3 years, the amount of older, thicker ice has actually declined. Whereas 52% of the ice used to be old and thick, only 19% of ice was old and thick in 2009. So aside from changes in sea ice extent, we've seen a huge reduction in total ice volume, such that most ice is now young and thin. And while it's more difficult to quantify ice volume than ice extent, models of sea ice volume show that the total amount of ice appears to be falling off of a cliff. Oh, but don't worry, sea ice is just fine. Trust me.